Dart School presents Multiplication 1. In this video, we are going to learn about the distributive property and how to use that in algebraic multiplication. Before we get into algebra, the x's, the y's and the z's, let's try and understand the distributive property with some simple numbers. Let's say you want to multiply the number 2 with the quantity 3 plus 4 that's inside the parentheses. Now, if you're aware about BODMAS or PEMDAS, as you might call it, you probably know that you need to work the parentheses first, which means you need to add the 3 with the 4 to get a 7 and then multiply that with 2. Therefore, the answer is 14. You could have also done this in a different way. You could have multiplied the 2 with each of the numbers that you have inside the parentheses. It doesn't have to be restricted to 2 numbers. There can be more numbers. And then add the 2 answers because you have a plus out here. Therefore, in this case, this would have been 2 times 3, which is 6, 2 times 4, which is 8, and 6 plus 8 is still 14. It's the same answer. This works with subtraction as well inside the parentheses. So if you have, let's say, a 10 minus 6 inside a parentheses to be multiplied with the number 3, remember, in multiplication, the order doesn't matter. It's called the commutative property of multiplication. Therefore, I could have written the 3 ahead of the parentheses. Like in this example, I have written the 2 down, or the 3 after the parentheses. It's just the same thing. The whole idea is, if you use the PEMDAS or the BODMAS method, you would do 10 minus 6, which is 4, and 4 times 3 is 12. And if you want to use the distributive property, you would multiply 3 with 10, you would multiply 3 with 6, and subtract the 2 answers because there's a minus sign in between. 3 times 10 is 30, 3 times 6 is 18, 30 minus 18 is equal to 12, which is what we have over here. And then, like I said, you could apply this to more number of numbers inside the parentheses. So you could have had 8 minus 5 plus 2 plus 1 minus 3, all of that multiplied with a 6. If you work the parentheses first and times that answer with 6, it would be the same as multiplying each of these numbers with 6 and adding or subtracting the next answer as per the sign as you see inside the parentheses. That leads us to the question, well, why are we going to do that? Doesn't that look more difficult or more complex than the BODMAS or the PEMDAS method? Well, one of the reasons why we use the distributive property is because it helps us in mental math. And another good reason why you want to learn and apply the distributive property is when you do not have numbers inside the parentheses that can be added or subtracted to give you one single number. For example, what would you do if you had something like 2 times and an x plus 3 inside a parentheses? You don't know what x plus 3 adds up to because you don't know what x is. Therefore, the best you could do it, either leave it like that or apply the distributive property, 2 with the x, the 2 with the 3, so it's going to be 2x plus 2 times 3 is 6. Let's do a couple more examples. Let's try and apply the distributive property in this expression. X squared times 4x minus xy plus 2. X squared is outside a parentheses. When you don't see a multiplication sign, it indicates multiplication. Therefore, depending on the need of the problem, we can apply the distributive property on this expression. We call it distributing the x squared on this. So it's going to be x squared times this, x squared times this, and x squared times this. Let's do that. X squared times 4x, x squared times xy, and there's a subtraction, so therefore we are going to subtract. And finally, x squared times 2. And there's an addition, therefore we are going to add them up. X squared times 4 times x is 4 times x cubed, because you have x times x, which is x cubed, minus x squared times x is x cubed again, y, plus 2 times x squared. We don't write x squared 2, we write the constant first followed by the variable. So this is what you get when you apply the distributive property on this expression. Let's do another one. Let's say we have negative a times b minus a minus 1. Once again, it's about multiplying the negative a with each one of the terms inside the parentheses. And because this is a negative out here, we got to be careful about the signs as we multiply. This times this times this. Let's go. Negative a times b, and then again we have a negative a times negative a. The two negatives will turn this to a positive. We will do that in the next step. And finally, a negative a times a negative 1, which will again turn to a positive. When you multiply a negative with a negative, you get a positive. Hope you know that. Therefore, this is going to be negative ab plus a squared plus a. Hope that helps.